All right, everyone, welcome back for Chapter 2 of our AWS Certified AI Practitioner Exam Prep Series. You ready to dive in?
Absolutely. Let's get started.
Okay, so last time we kicked things off with an overview of AI concepts. Today, we're taking a closer look at the machine learning development lifecycle, specifically focusing on the steps in AWS services that can be leveraged at each stage.
It's like a roadmap guiding us from raw data to a fully functional AI model.
Right, like an assembly line for building intelligent models.
Exactly. Each stage in the ML pipeline plays a crucial role, just like each station on an assembly line.
Okay, so let's break down this pipeline. Step 1, data collection.
This is where it all begins. The quality of your data is paramount. Remember, garbage in, garbage out.
Makes sense. A model is only as good as the data it's trained on.
Exactly. Imagine a financial institution using a model trained on inaccurate data to assess loan applications. Could be disastrous, leading to unfair lending practices and potential financial losses.
Wow, that's a scary thought. So how can we ensure good data quality from the start?
Well, first, you need a clear objective. What problem are you trying to solve? What kind of data will help you answer that question? Once you know what you're looking for, you can focus on collecting relevant, accurate, and representative data.
Okay, so it's all about having a plan and purpose before you even start collecting data.
Exactly. Think of it like planning a road trip. You need a destination in mind before packing your bags.
I like that analogy. Okay, so we've got our data. What's next?
Time for data cleaning. It's all about smoothing out those bumps in the road, ensuring data integrity and reliability.
So we're talking about identifying and correcting errors, inconsistencies, and missing values.
Precisely. Think of it as meticulously inspecting your data, removing duplicates, fixing formatting issues, and handling missing data.
And I imagine this is particularly important for avoiding bias in our models.
Absolutely. If your data is skewed or unrepresentative, your model will perpetuate those biases. For example, a facial recognition model trained on a data set predominantly featuring faces of one ethnicity might perform poorly when presented with faces of other ethnicities.
That's a powerful example. Okay, so we've gathered our data and meticulously cleaned it. What's the next step in our ML journey?
Now it's time for some exploration. Exploratory data analysis, or EDA, is all about uncovering hidden patterns and relationships within your data.
So it's like putting on our detective hats and searching for clues.
Exactly. EDA helps you understand the characteristics of your data, identify potential outliers or anomalies, and gain insights that will inform your model selection and feature engineering process.
It sounds like EDA is where we really start to get a feel for our data and uncover its hidden stories.
You got it.
Yeah.
It's about asking questions, testing hypotheses, and letting the data guide your decisions. The more you understand your data, the better equipped you'll be to build a model that accurately reflects the underlying patterns and relationships.
I love that.
Okay.
Okay, so we've explored our data and hopefully unearthed some valuable insights. Where do we go from here?
Now we move on to data preprocessing. It's where we refine our raw data into a format suitable for training a machine learning model. Think of it like preparing ingredients before you start cooking.
So we're talking about techniques like feature engineering, feature selection, transformation, creation, and extraction.
You nailed it. And feature engineering is where we get to be creative, using domain expertise to transform raw data into powerful predictive variables.
Ooh, that sounds interesting. Can you give us an example?
Imagine you're building a model to predict customer churn for a streaming service. You might have raw data like the user's sign-up date and their last login date. Feature engineering allows you to create new features from this data, such as the number of days since the last login or the user's average session duration.
Ah, I see. Those new features might be more informative for the model than just the raw days themselves.
Exactly. It's like adding a secret ingredient to the recipe, a dash of domain expertise that can make all the difference.
Love that analogy. And just like with cooking, we don't want to throw in every ingredient we have.
Right. Feature selection is about choosing the most relevant features for your model, the ones that will contribute the most to its predictive power.
So it's about finding the right balance, having enough information to make accurate predictions, but also avoiding a model that's too complex.
Precisely. And sometimes the features we have aren't in the right format for our model.
So that's where feature transformation comes in, right? Things like converting categorical data into numerical data or scaling features.
Exactly. Techniques like one-hot encoding, standardization, or normalization ensure that our data is in a format that the algorithm can effectively process.
Got it. And what about feature creation? Is that where we can get really creative and combine existing features?
You got it. Feature creation is about combining existing features to create new ones that might capture hidden relationships in the data. For example, you could combine a user's age and income to create a new feature representing their purchasing power.
Makes sense. And finally, feature extraction. What's the purpose of that step?
Feature extraction is all about simplifying our data by reducing the number of features while retaining the most important information. Techniques like principal component analysis or PCA can help us create a smaller set of features that still capture most of the variance in the original dataset.
Sounds like data preprocessing is a crucial stage in setting the stage for a successful model.
Absolutely. Just like a chef wouldn't throw raw ingredients into a pot, we can't expect a model to perform well without carefully preparing the data.
This has been a fascinating look at the early stages of the machine learning lifecycle.
It's all about laying a solid foundation for building a successful model.
So what's next in our journey? Where's the real magic of machine learning begin?
Well, next time, we'll dive into the exciting world of model building, where we'll select the algorithms that will bring our data to life and transform it into intelligent predictions.
Can't wait. Join us next time for part 2 of our deep dive into the machine learning development lifecycle.
Welcome back, everyone. So last time we laid the groundwork. We talked about data collection, data cleaning, and exploring all those hidden patterns.
Yeah, we really prepped our data for the main event, model building.
Now it's time to pick the brains, the algorithms that will bring our data to life, help us make some intelligent predictions.
Okay, so let's imagine we have our toolbox in front of us. What are some of those key algorithms we should know for the AWS AI Practitioner exam?
Well, the exam covers quite a range, but some of the big players are linear regression, logistic regression, decision trees, support vector machines, and of course, neural networks.
Wow, that's a lot. It's like having a whole arsenal at our disposal. How do we decide which one to use for a specific problem?
That's where understanding our problem and data comes in. So if we have a regression problem like predicting house prices, linear regression might be a good starting point.
Right, linear regression finds the best fit line to show the relationship between our input features and the target variable. What if we were trying to categorize data, like with spam detection?
Then logistic regression could be a better choice. It gives us a probability score telling us how likely it is that, say, an email is spam.
Okay, that makes sense. And what about decision trees? When are they a good fit?
Decision trees are really versatile. They work for both regression and classification tasks. They create a tree-like structure to make decisions based on features. They're great when we need to explain how the model made a prediction, for stakeholders.
Right, transparency is key, especially for ethical concerns.
Yeah.
What about support vector machines? Those sound kind of complex.
Yeah, they can sound intimidating, but basically they are finding the best way to separate different classes of data. Really effective for high-dimensional data.
Gotcha. And finally, the star of the show, neural networks. When do we use those?
Neural networks are inspired by our brains and learn complex patterns from tons of data. They're great for things like image recognition and natural language processing, but they can be resource-intensive and need a lot of data.
So it sounds like choosing the right algorithm is a bit of a balancing act.
Yeah, there's no one solution. It's about experimenting, trying different algorithms, and seeing how they perform.
Okay, let's say we picked our algorithm. What's next?
It's time to train the model. We feed it our data and let it learn the patterns and relationships.
Like sending our model to school, right? Give it the knowledge to make smart predictions.
Exactly. And the better the training data, the better our model will perform.
So what do we need to think about when training a model?
Well, the size of the data set is important. Generally, more data is better, helps the model learn those complex patterns. And then there are hyperparameters.
Hyperparameters, those sound mysterious.
They're like the settings that control how our algorithm learns. They're set before training and can really impact performance.
Like fine-tuning a camera to get the perfect shot.
Precisely. And just like with photography, finding the perfect settings often means experimenting, using techniques like grid search or random search to find the best combination.
So training a model is part science, part art.
It is. It's a journey of discovery, learning from our data, and refining our approach along the way.
Okay, so we've trained our model, adjusted the settings. Now what? Do we just deploy it?
Not so fast. Often the first model is just a starting point. Next, we evaluate it, put it to the test.
Give it a pop quiz to see how well it's learned.
Exactly. We see how it does with unseen data it hasn't encountered during training.
Because we want our model to work in the real world, not just with familiar data.
Precisely. And for that, we need metrics to assess its performance, to understand its strengths and weaknesses, and guide us to make improvements.
Okay, let's talk about these metrics. What are some of the key ones for the AWS AI Practitioner exam?
You'll need to know accuracy, precision, recall, F1 score, and AUC, to name a few.
Those are a lot. Can we break them down quickly?
Sure, accuracy is straightforward. It tells us how many predictions are correct. But it can be misleading, especially with imbalanced data sets.
Imbalanced data sets, what does that mean?
It means one class has a lot more data points than the other. Like in fraud detection, there are way more legitimate transactions than fraudulent ones. If our model just says every transaction is legit, it might have high accuracy but not be helpful at all.
Ah, I see. Accuracy isn't the whole picture. What other metrics give us a better view?
Precision and recall are useful for classification. Precision is about how many positive predictions were right, while recall is about how many actual positive cases we caught.
So precision is about minimizing those false alarms, and recall is about making sure we don't miss any actual positives.
Exactly. Then we have the F1 score, which balances precision and recall. It's handy when we need to find a middle ground.
Gotcha. And lastly, AUC. What does that tell us?
AUC, or area under the ROC curve, measures how well our model can tell the difference between classes, how good it is at separating the positives from the negatives.
So it's all about how well it discriminates.
Exactly. Choosing the right metrics is key for getting a real sense of how our model is doing.
So we've evaluated our model, seen what works, what doesn't. What's the next step? Do we just deploy and call it a day?
Well, not quite. The first model is often just the beginning. We need to improve it, make it ready for the real world. That means tweaking those hyperparameters, maybe trying out some different features, or even exploring other algorithms.
So it's an ongoing process, always trying to build a better model, right?
It is. It's important to keep track of what we're doing, document our choices and make sure we can repeat our results. This is where MLOps comes in, but before we jump into that, maybe we should recap what we've learned about model building so far. Okay, so where were we? Oh yeah, we were talking about model building and all the different algorithms.
Yeah, it's been quite a journey, from picking the right algorithm to training it and then putting it to the test with all those metrics.
And it all starts with the data.
Right.
Making sure we have good quality data that's clean, and then exploring it to find those hidden patterns.
Right, like we talked about, using visualizations to help us understand our data, and then using feature engineering to create new features that give our model more predictive power.
Yeah, feature engineering is like adding that secret spice to our recipe. A bit of domain expertise can really make a difference.
Absolutely. And then we have to choose the right features. Not too many, not too few, just the right amount to avoid overfitting.
Exactly. And then there's feature transformation, making sure our data is in the right format for our chosen algorithm.
And who can forget feature creation, combining those features in new and creative ways to capture those hidden relationships.
Right. And then there's feature extraction, simplifying our data while keeping the important stuff.
All those steps are really about setting the stage for building a successful model.
Exactly. Then comes the fun part. Choosing the right algorithm for the job, whether it's linear regression, logistic regression, or even those powerful neural networks.
It's like having a toolbox full of tools,
Mm.
and we need to pick the right one for the task at hand.
And once we've chosen our tool, we have to train it, feed it data, and let it learn those patterns.
Right, making sure we have enough data and that we're adjusting those hyperparameters to get the best performance.
It's like sending our model to school, giving it the knowledge to make smart predictions.
And then comes the test, evaluating our model, seeing how well it performs on data it's never seen before.
Using those metrics, accuracy, precision, recall, F1 score, and AUC, to see how well it's learned.
It's like a report card, telling us where our model shines and where it needs a little more work.
And just like with students, there's always room for improvement. We can tweak those hyperparameters, try different features, or even explore other algorithms to boost performance.
It's a continuous process, right? Always learning, always refining.
Exactly. The world of machine learning is constantly evolving, and so are our models.
So as you prepare for the AWS Certified AI Practitioner exam, remember all these steps, think critically, and don't be afraid to get hands-on and experiment.
And remember, the exam is all about applying these concepts in real-world scenarios using AWS services. So think about how those services fit into each stage of the life cycle.
Great point. Well, folks, that brings us to the end of our deep dive into the machine learning development life cycle. We've covered a lot of ground today, But this is just the beginning of your journey into the exciting world of AI.
So keep exploring, keep learning, and who knows, maybe you'll be building the next groundbreaking AI model.
And be sure to join us next time as we continue our AWS AI Practitioner Exam Prep series. We'll be diving into another fascinating topic that will help you ace that exam. Until then, happy learning.